I'll be talking about challenges in legal reasoning with LLMs. I'm Mahmud Elahi Akhter. Nice to meet you all. I'm doing fine, don't worry. This is but a flesh wound. Um, Although the use of LLMs has proliferated in various domains, showing impressive capabilities in plethora of tasks, reasoning still remains like an open problem. It's currently the holy grail of all proprietary LLM companies, and it's still very much being worked on. So here, let's start with this example. This is from Twitter, from when Quen came out, and we can see that it's what is the last word in this question? The last word in the question is that. So a very nice case of failure. Now, if we move on to legal cases, here we have a legal context that pertains to personal jurisdiction of state court in the US, and there's a case context, and the task of the LLM was, here's the question, does Oregon court have personal jurisdiction over defendant if he is not in Oregon? And the LLM had to give answer to this based on the legal and case context. Let's see. First, let's see the actual deductive steps we require for the correct answer. So first, we have the context evidence here, 1 and 2, that gives us A, that Mitchell can sue Neff for his fee in Oregon State Court. One quick bit is, let me go very quickly over the case context. Neff hired Mitchell, then Neff fled without paying Mitchell his $300. Mitchell is a lawyer, and he sued. Then Neff came back to Oregon, he got served, then he fled again, and that's where the question comes in. So the context evidence gives us, yes, Mitchell has sued Neff, he can do that. Then we come to more context evidence that aligns with the case evidence that says that based on 3 and 4, the court can ask a sheriff in a state to seize a defendant, and such authority can be exercised in a symbolic manner by the sheriff by serving the individual. And based on statement 4, we can come to this part of case evidence that indeed Neff was served with process in Oregon while Neff was visiting there on unrelated business and then left. And finally, the context evidence in 5 gives us the conclusion that Neff was served in Oregon, therefore Oregon court has personal jurisdiction over Neff, regardless if Neff is in Oregon or not. This was asked to Mistral. Quickly, this is from this paper. I guess we cannot see it there, so look at that screen. Okay, this was asked to Mistral. What did Mistral say? So obviously Mistral got it wrong, very wrong. Step 1, we have false inference. The model infers that court has personal jurisdiction over a defendant only if they're present in the state. There is no mention of what happens when a defendant is being served while in the state. Step 2, we have irrelevant evidence, like while the model has access to the fact that Neff was served with a process while in Oregon, it cannot draw the inference needed from step 1 and instead focuses on irrelevant information. Step 3, wrong inference from previous steps. That leads to a false premise that a court only has jurisdiction over someone present in the state. And finally, wrong conclusion in 4 due to previous wrong deductive reasoning. So here we can see in a legal case how a model gets steps wrong that leads to failed reasoning. Now, let's do a quick refresher on what atomic reasoning types are, like deductive and abductive. Deduction is a reasoning type, which is a conclusion Q inferred directly from some premise P. Here, for the example, we have incident regarding Charlie Hebdo incident, where we can deductively infer from example Q that schools have been closed, citizens have been told to stay home, and it is likely the town is in a warlike situation. Therefore, P infers Q. And on the right, abduction, we have abduction is a bit more tricky. Abduction is when you don't have full set of evidence and you have partial evidence and you need to do best possible case of guessing. You need to infer something that's not there. Here, the example is Pluto's climate change over the last 14 years is likely a seasonal event. However, in evidence, we are talking about Neptune, how Neptune has a season, how it's experiences similar seasonal change to Earth, and like we have the statement here, each planet therefore has seasons, changes to climate over the course of its years. So we can use this partial evidence and infer that, okay, Pluto used to be a planet, now it's a dwarf planet, but it still likely has similar attributes, and therefore it likely has, climate change over last 14 years or more. So that's abduction. We don't have the full evidence, but we can infer from the partial evidence. Now, I'd like to discuss the work we did in our paper. We assessed reasoning capabilities of LLMs on deductive and abductive reasoning for claim verification. So let's start with this. We first proposed this framework that we synthesized from literature that highlights the interconnectivity between different reasoning types, process, and task. So where to start? We distinguish between atomic and compound types. Atomic types are deductive, abductive, inductive, and analogical. These are the most basic reasoning types, whereas compound are built up with atomic types like causal, common sense, temporal, spatial. All of these use some form of atomic types. Whereas when we come to composite tasks like legal, social reasoning, gameplay, all this stuff, you will have mix of atomic and compound. You will have deductive, abductive, you'll have some temporal, causal, and so the reasoning process in red, that's interaction between reasoning types or tasks with different levels. So for instance, multi-hop is when you have multiple steps. For instance, the example we saw, it had multi-step deductive reasoning. So process interacts with all of them. Here's a use case of how the framework can be used. So here the reasoning task was claim verification. The process was single step, and this is atomic abductive. The claim was the grass in the garden is wet, and it is currently the peak summer season. The evidence was there are water droplets on the leaves, and the ground is damp. So we can come to the plausible hypothesis that it rained last night or dew formed overnight. But dew doesn't form during peak summer season. So the veracity is, yes, it rained last night. So the veracity is supported. As I said, we've already seen this multi-step deduction, and from the context and case evidence, we can come to the answer of this question. And this is a legal QA. Reasoning process is multi-step, and reasoning type is atomic deductive. So using our framework, we annotated some data. We annotated 3 data sets. These are vitamin C, climate fever, and Feme Plus. These come from different sources. Vitamin C is synthetic, comes from both claim and evidence come from Wikipedia. Climate fever, the claims come from internet, evidence is Wikipedia, whereas Feme Plus is coming from Twitter. And the blue shades show all the deductive, and the yellow and orange show all the abductive. So deductive reasoning is much more overrepresented compared to the abductive in all of the data sets. This was how we did our evaluation. Let me give a quick refresher on prompting. So we are all on the same page. We can ask LLMs question in many different ways. We call that prompting. So prompting, the most basic type is zero shot, where we'll ask a question like a juggler can juggle 16 balls, half of the balls are golf balls, blah, 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 how many golf balls are there? Just a basic question, and we expect it to give us an answer. Now, we also have zero shot chain of thought, where we'll ask the question, but we'll also start with let's think step by step. We'll end our question with that. So this will trigger the LLM to go into this reasoning chain that's supposed to elicit, better answer. Then we have manual caught, where we'll give an example and break down the reasoning chain, and then ask the question that aligns with the example. And this is, again, this is the best possible performance-wise prompting method when it comes to chain of thought so far in vanilla settings. And we evaluated our LLMs in two different settings. In one, we asked them to give rationales for their decision, like, okay, why do you think this is true or false? In another one, we said, like, okay, you don't need to give us any rationale, just say if this is true or false. Very big heat map. So let me just say what this is. Vitamin C, D, this is a typo, this should be A. Vitamin C, these are deductive, abductive, deductive, abductive, deductive, abductive. This shows like, this is relative, how bad the error rate is, the abductive error rate is compared to deduction. If you see, like, most of them are almost 3 times. So LLMs are horrible when it comes to abductive reasoning. They are somewhat okay when it comes to deductive reasoning. Here, what we're looking at is the impact of data domain. So vitamin C is purely from Wikipedia, and you can see the performance is between 0.85 and 0.90, very high performance. Whereas on the right, we have Theme Plus, which is from Twitter, and you can see that the performance is lowest here. Twitter data, social media data, very noisy. And in the middle, we have Climate Fever, very high variance. It varies from 0.70 to like almost 0.93, I guess. And as you can see, the claims are from real world, whereas the evidence is from Wikipedia, and the performance varies highly. And it's across different kind of prompting settings. So in short, LLMs are good with deductive reasoning, but cannot perform abductive reasoning well, at least from what we found. And even for deduction, performance varies highly depending on the data domain and task complexity. However, we just saw that it failed a legal deductive reasoning problem, and that was very trivial. It was like, based on some legal context and case context, does a court have jurisdiction? So yeah, the data domain matters, the task matters. So how can we improve deductive reasoning? So here I will present Xinggui's work, where we work to improve deductive reasoning through symbolic logic. I'll get that to it in a bit. So most reasoning LLMs, such as DeepSeek, OpenAI, Qwen3 perform deduction, and the reasoning trajectory should contain the intermediate atomic deduction steps required to reach the final answer, the one we saw previously. However, reasoning trajectories generated by current LLMs are not necessarily suited for logical reasoning, as they often are verbose and redundant. Sorry. The symbolic reasoning we were talking about. So this is the verbose output of a reasoning step that's in formal language. Informal language, then we can use formal logical translation to make them into symbolic structures. So here we use quantifiers to convert this to this. And we argue that this will improve the deduction capabilities. So here we can see the standard prompting, how it's susceptible to content bias, lack of generalization, whereas we use symbolic prompting, convert the prompts into symbolic reasoning trajectory, symbolic reasoning presentation. Then we have symbolic reasoning trajectory, and the LLM is guided by, LLM is symbolically guided. Here we'd like to show the results. We experimented on 2 logical reasoning data sets, Folio and LogiOscar. Folio is an expert-written dataset that consists of first-order logic reasoning problems, which require models to decide the correctness of conclusion given a world defined by the premise. Again, this is like synthetically generated. This is not like taken something from the internet or the real world. LogiOSCAR is also a synthetic dataset where logic rules were used as prior to generate formal logical reasoning problems, which are then translated into natural language. Both dataset were created using formal logic rules. And as I said, neither reflect the intricacies of real world scenarios. For each question in the dataset, the model needed to determine whether a statement is true or false given a set of premise. We found that changing the format prompt from React to symbolic React, which guides LLM to reason in first order logic, can increase the accuracy of frontier models like 4o and DeepSeek V3. Meanwhile, in fine tuning on the samples trajectories, improve smaller models like Quen and Llama. Here, we also, as stated, like those were not real world data. Our RECV benchmark had real world data, except for vitamin C. That was basically a control. So here we saw the performance, and yes, performance was, at least for Llama and Quen, for smaller models, performance isn't bad, but we can still see that abduction is still bad. The models cannot do abduction, although it improved a bit with symbolic reasoning compared to like baseline process GPO. But we can see that, yeah, abduction is still horrible. And so far, I've discussed the challenges LLMs face when it comes to reasoning with real world data set. And legal reasoning is much more complex than the data sets we have discussed so far. It has much more different domains of data coming in, different types of reasoning coming in. So it's much more compound, much more complex. This means like, yeah, LLMs are very much likely to suffer there for nuanced examples. And this means we also require more robust evaluation methods for legal reasoning or more complex reasoning tasks. And so far, we've looked into performance aspect of LLMs. And now I'd like to invite Guneet, who will look into the evaluation aspect of LLM legal, at least in context of legal reasoning.